been feeling so small. Watch the clock ticking off the wall. But
Good day, everyone. My name is April Jane S. Ganya from BTLED IA2A. For today's video, let's tackle about the different parts and functions as well as the different types of differentials. There are four differentials used between vehicles: open, locking, limited slip, and torque vector. We're going to explore what differential is and how various differential designs operate when the vehicle is turning each of its wheel, travels along a different path because each path is a different length. Each wheel has to have the ability to rotate at a different speed in order to allow the wheels to turn at different speed. A differential is used power supplied from the engine through the transmission to a drive shaft, which connects to a differential. A pinion gear is attached to the end of the drive shaft. This turns to ring gear. The ring gear surrounds a set of differential gears that enables two rear axles to turn at different speed. When the vehicle is traveling straight, the left and right axles turn at the same speed. When the vehicle is turning, the difference in rotating speed between the two axles is compensated for by the differential's gears. Notice that the pinion gear turns at a different speed than the ring gear. The ratio between these two gears is called the axle ratio. So the ring gear turns one time for every 4 revolutions of the pinion gear. This axle would be said to have a 4:1 ratio. By changing the axle ratio, the torque multiplication and top speed is changed after increasing and decreasing them. Axle ratio is an important component of the transmission gear ratio. Little maintenance. However, the major disadvantage of an open differentials is that the engine power follows the path of least resistance. This means that in cases where one wheel has less traction than the other wheel, the engine's power will go to the wheel with the least traction. A way to limit this loss of traction is to limit the amount of independence between the two axles. This can be accomplished through a number of mechanical, electronic, or hydraulic systems, which are known as limited slip differentials. The benefit of a limited slip differential is that the amount of power sent to the wheel with least traction is limited, so that the wheel with most traction receive continuous power in order to get the vehicle moving. The disadvantage of a limited slip differential is the amount of power that can be transmitted to the wheel with traction is also limited. The next type of differential is known as a locking differential. Locking differentials have mechanism that can literally lock the two rear axles together when needed. When a locking differentials, both axles receive equal power so that the wheel with the most traction will always have power. Locking differentials are often used for heavy-duty, off-road, or other low-traction situations. The disadvantage is that they have to be unlocked to allow differential wheels speeds. During turning, if the axles are locked, during turning, handling is negatively affected, an alternative to differential. Base LSDs and locking differentials are brake-activated LSDs such as Toyota's Auto. LSD systems brake-activated LSD use an open differential but selectively apply the brakes to the wheels with least traction. This take advantage of the path of least resistance to transfer power to the wheel that isn't having the brake applied. The Auto LSD system is designed primarily to improve traction at times when the vehicle is likely to get stuck. The system electronic control give it better torque transferring abilities than other types of differentials. Other benefits of these systems are that they require fewer parts or less complex than mechanical system that reduces maintenance and weight.